In this video, I'm going to continue from the previous video, giving dimension to particle structure of underlying particles. In that video, actually, in plotting, I didn't actually connect those lines. It was like a bit of confused that they were not actually line, they might be a particle. So in this video, I'm going to connect them just by using, instead of O, I'm going to give O dash. Yep. Once that has been done, I would, this is pretty much the same code. X-axis, y-axis, their z coordinates, bounds. Yes, I'm giving for every particle same velocity, -1, negative, and I guess it's pretty much the same. And actually I'm considering it to be actually having 0 velocity in x and y direction. So its direction coefficient of velocity vector would be 0 in these two things. This is pretty much the same and just played out. You will see they are connected now. Look, they are connected. If you change the coordinates, doesn't matter. Keep it 5 and keep it 5. Just play it out. Yeah, they are connected. You can see now they are connected. In the previous video, I didn't actually put this dash in there. You can put simple dash or whatever you want to actually show how it looks. It's a way of showing it. Type of line they are connected. I'm using O dash. Okay, yeah, one more thing I have just did a little bit changing. Like in previous state function, structure state, I was going for loop for every point, every particle. So I have made a little change. I'm going to use the particle coordinates as it is. So I am removing that thing. So what does this mean? This is x coordinate initial, final, and this is x coordinate, this is y coordinate, and z coordinates. So it is a general thing. Velocity, if Lx is 0, then this would be like 0. It won't have anything like vector component in x would be 0 because vector is not making this velocity vector is not making any angle with x or y axis. They're 0, and there will be only velocity in this axis. Now you can, this is more generalized state function. And also made that if minimum of x is actually less than the bounds, maximum is greater than the bounds of px2, it will just be minus. It will be like the previous state. And pretty much everything is same from the last video. So let's play this thing out, and I'm giving this lx, my, and ny value here because now lx and my and z has meaning to it. This is more generalized function. This stops here. It won't go any further. But there's one thing, like as a particle, they should drop. That is why I told you center of mass will be needed for the stability. So here it's unstable. If enough force is not given here, this thing is unstable. This will be coded in subsequent lectures, how to get stability in this part, and it should drop. We can do that in any other videos. For now, you just remember, for the stability we need center of mass, like I told in the previous video. I think this is pretty much it. Now you can actually increase the number of points to it. It doesn't even matter. So getting the same x, y, and z, you can increase the number of points. Center of mass will be changed as accordingly. You keep them in straight line so that you won't be confused about the stability. And this time keep it at 15, let it fall along z axis. We can give different velocity in different direction as well. So something is wrong. Yep, here I have to give velocity for 4th particle as well. You will be like, why is 4th point not shown? Because center of mass and this is colliding with each other. The thing is that they're colliding. So you can actually go for something else, 13 over 13. Now you can see different center of masses. Otherwise it was 15 was center of mass and point was also at 15. I think this is pretty much it for this video.